What happened?
For me, it's something that I wish we did in our lab here. It was a qual experiment. A qualitative qual experiment. Anybody? Oh goodness, yeah, someone older has done it where they did the qual experiments, but it was where you were given an unknown, and you had to go through a series of tests, and it's essentially a flow diagram. Add this, you get a precipitate. You get a precipitate that could be one of these things. Then you do a different set of tests. And excuse me. Yeah, and to me, it was so cool because it turned out I got it. And you can take samples and they burn in different colors. So potassium burns red, and sodium is yellow, and so you can put chlorine's green. So you have to remember these too, but you take them and dip them, and you can do flame test, and just all sorts of different. And so I was fascinated by that, and the logic and the flow to that.
Yeah, I think a similar thing happened to me in high school. If you ask almost any scientist, they'll tell you there was one specific high school science teacher who motivated them. And I was lucky, I had two of them. I had one in biology, and I had one in chemistry. And the guy in biology let me go out by myself and set me aside and let me just work on experiments that I wanted to work on. And the same thing in chemistry, what I did, since he saw I was bored with the regular labs, he gave me a qualitative assignment to work out. And as you said, it's very interesting when you follow the flow diagram, you see the logic, and you get this result or that result, and come out to the end. I think that's where I decided specifically I wanted to be a chemist.
You know, it's interesting, I just realized that's very similar to what a physician does with the differential. It's occurred to me. So, a physician, when you go in and you present a complaint, when they see that complaint, there's a number of different possibilities that it can be. And then they look through and they ask a series of questions, and essentially a differential is all the possibilities, and then when you ask another set of questions, you get a whole other set of possibilities. So that's what a qual experiment is.
Questions?
Yeah. The science itself is a broad discipline. It's got psychology and chemistry and physics and whatever it is. I can't think of all of them. But when you guys do your research, what type of methods do you use to help you solve your skeptical questions or your hypotheses? Is there something is it something that can be shared, can be related to all the scientific disciplines? Or is it just something that's related to chemistry?
In general, it goes back to this idea of the scientific method.
Yeah.
That underlies no matter what area of science you're doing, whether you're doing chemistry or biology or even psychology. So it's the idea of formulating a problem you want to work on. You look at something in nature and you say, I want to understand this better. I want to somehow understand how this works at a level that no one else knows at this point. And then you devise some experiments to test and get information about it. And then you try to come up with an explanation of those results, which is an hypothesis. And then you design new experiments to test whether that hypothesis is right or wrong. And if it's right, actually, as David said, you want to try to find experiments that say it's wrong. But if it's right, then you go on and do more different variations of how it's approached, but the underlying idea is the same.
I think that if you're constantly questioning your own results,
Yes.
you're more likely to what you find and what you end up writing and publishing in the end is going to stand the test of time. I think for me, one of the hardest things that would ever be to take is to publish something and to find out I made an error in it. Yeah. And to have that out there forever. And even if the error was accidental or I missed something,
person, you have a community of people that you rely. How do you depend on it? Is it consistent? Do people stay in that community for talk a little bit about what the community of experts are, and what do they do for you as a disciplined person?
Well, I think the community of experts gives you a sort of baseline grounding on how to evaluate something. And you're more apt to believe something is true if you have a community of experts to back you up. And being the skeptical person I am, though, I don't always agree with the community of experts.
You say you don't always agree with them?
I don't always agree with the community of experts.
Is that part of being a skeptic?
It's part of being a skeptic.
Probably a scientist.
I think it is part of being a scientist.
You said something about emotions too.
About what?
Emotions,
Yeah.
getting involved. And I believe the underlying theme for most people with a disciplined mind is the challenge, it's the thrill, it's the reward, it's, what you receive. What is the longest amount of time that you have spent on an experiment?
The longest amount of time I've ever been on these.
I mean, just staying in the lab all night long.
Yeah, that's
Yeah.
It's happened. I worked on a project in grad school involving particular enzymes, and you had to start out with some raw material from plants, and then you had to purify that and eventually come up with the pure enzyme. And that, as David knows, can be a very long process because you have to run them through different purifying equipment and columns, and you have to be there to make sure everything's operating properly, because you don't want to invest like 8 hours on an experiment and go home at night and come back the next day and find out that something went wrong. And if you'd have been there, you would have noticed it and corrected it. So I'd say, I spent, in graduate school, I spent a couple of nights, all night, running experiments. So, 15, 18 hours at a time.
Did you feel, were you tired, or were you just motivated, just driven? You didn't really think about the time. You just kept at it.
Sometimes I was motivated. I can't say all the time.
Okay.
I was interested in seeing what happened. Other times, it was just a matter of I knew I had to be there. I knew it was the prudent thing to do. And I might have been bored to death watching the equipment work. But if you're committed to the experiment, if you're committed to doing good science, then it's something you have to do.
Dr. Berg asked you guys about community of the peers. To me, the answer was kind of wasn't complete enough for whatever reason. I'm gonna ask it another way. Your peers in your group, are they kind of consistent, or because of the economic ways of today, have they changed? Is your group of peers pretty consistent?
I think it depends on what area of research you're doing. Research is a big business these days.
Yes.
It requires enormous amounts of money. And once a person has established themselves and gotten these enormous multi-million-dollar grants, it's easy for them to become part of the peer community. And once you've established yourself in that fashion, it generally doesn't change that much. So you generally have a core group of these people who are very good at writing grants and getting the big money that takes to do the big science these days. So since individuals don't enter and leave that cohort very frequently,
Okay.
it's become sort of an established group over a long period of time.
Because I didn't quite understand, because it sounded, it was kind of like a revolving door almost for a minute there, because you see these guys get these different opinions and might, kind of stray from, get mad or something. You kind of clarified that a little bit.
I'm sorry, I missed that part. What did you say?
Okay, it sounded to me like it was kind of like when Dr. Burke first asked the question, about the peer community. It sounded like these guys and the other ladies' comments about the guy, the unethical guy, and it sounded like at times could be at odds within a group.
Yeah. It doesn't mean that there's not a lot of rivalry within the group.
It exists,
It
but
exists.
it doesn't mean you want to tear each
Oh,
other.
actually, rivalry is,
It's everywhere.
yeah, it's certainly there, and actually that's part of the, I think that's part of the driving force.
Mhm.
There was, my research when I was a graduate student was trying to understand this one protein, and there was a scientist in Germany who was working on the same thing. And we had different ideas of how this would turn out. I think in the end, the idea won out, but he was well established, and actually my mentor was well established as well. So that was part of the fun. And actually, when we went to a meeting, when we were all there, and to get to meet him, he was my rival, but still to get to meet him was cool. And even though I don't know, I think we need to be careful and pull back. I think most scientists really do want to publish good results. I would still say it's more rare that scientists is trying to pull the wool over someone's eyes.
At least explicitly. I mean, there can always be unnoticed bias in your results.
Yes, I would agree with that.
And, if there are two ways of interpreting things that are equally good, and the one way fits more with your line of thinking, then of course you're going to steer yourself in that direction usually.
Came across something in my reading, this was on scientific scholarship in this one book. What science is often associated with objectivity. Is science really objective? If by objectivity you mean suspension of values, science is definitely not objective. However, if by objectivity you mean standardization, science is indeed objective, or more accurately, aims to be objective. The scientist attempts to look at the world in such a way that other observers trained in the same way, using the same methods, would see the same thing. Replication of a study will yield identical results. In a sense, that's what I view what a scientist is doing. It doesn't mean that there isn't that emotional side,
Right.
but aims to try to keep that in check.